Okay, sige, ito na. Start ko na yung PowerPoint. Um, Here we go. Teka. Yan. Present now your your window. Okay, ito. There we go. Yan. So, okay, unang na sa lahat, yung birthday pala ni Mo ngayon. Happy birthday, Mo. Yun muna. Batiin nyo siya. Next. Yan, birthday pala ni Mo ngayon. So ngayon, we're going to start with Waves and Acoustics. Ayan, so physics ulit to, no? Kasi kakatapos natin ng chem. So, new topic ulit to. Ito yung pagpapatuloy ng kaunti from oscillations, yung simple harmonic motion, di ba? We're going to explore that behavior in a more general sense, no? Waves, and we're going to focus on sound waves mamaya, no? Yung light waves sa grade 11 pa yon. Okay, sige. So, waves, basic components or terms lang. Waves is, ito, keywords agad to, is a disturbance. Disturbance siya that travels through a medium. Kumbaga, para mag-propagate yung wave, kailangan may dinadaanan siya. Example, sa tubig, di ba? Kapag nag-swimming ka, ayun, pag tumama yung kamay mo, disturbance yun, di ba? Yung disturbance na yun, travels through waves. Kaya nagkakaalon ng kaunti pag nag-dive ka, pag nag-freestyle ka, di ba? Transporting energy, no? Transporting energy from one location, which is its source, to another location. Pero hindi natatransport yung matter. Kasi example, pag ba umalon, nawawala yung tubig, di ba? Hindi. Tumataas lang siya, bumababa ulit, di ba? Ayun, that's the analogy that we have, you know? Okay. So, ito, ayan. See? Ito pa yung sabihin. Yung particle sa wave, akyat baba lang siya most of the time, di ba? Hindi gumagalaw yung particle mismo. As long as hinahawakan mo yung isang end, di ba? Then the velocity of the wave, yan, it goes to the right. For this kind of wave only. This wave, as shown, is periodic siya, di ba? Periodic siya. Kasi umuulit lang siya, di ba? Same. After one cycle or period, uulit-ulit siya. So, parts of a wave, na-discuss na natin to, pero may dadagdag tayo. Beside him, crest and troughs of the sea of light that flows, di ba? Yun yung ibig sabihin noon. Crest is yung pinakamataas na point sa, amplitude yan, di ba? Pero crest yung above x-axis, trough yung nasa baba most of the time, di ba? And ito yung wavelength. Yan. Ayun, amplitude, maximum depth or height of a wave, wavelength, distance between any two successive identical points in a wave, frequency, number of complete cycles that pass through a point in a given time, and period is time required to complete the cycle. Wave speed, diba? Wavelength, diba? Wavelength yung distance, no? Wave speed, ano yung speed ng wave? Same pa rin, distance over time. If we simplify that, lambda f, no? V equals lambda f. Super important yan. Okay. Sige nga. Ngayon, given kayo nito, I want you to tell me kung ano yung wavelength ng A at B. Sige nga, let me test you. Pwede nga ba kunin to? Let's see, 2 minutes lang. Sorry. Pwede nga ba makuha? V equals... okay. Pwede kaya yun? Hindi, guys. Never mind. Skip to. Skip. Medyo... May mali ako nang nakuhang tanong. Sorry. Pero, wait. May sagot pala kayo. Sige, let's see. For... Find the wavelength. Hindi, ano siya eh. X versus... sige guys, ito na lang. X versus T eh, di ba? Mali ako nang napiling graph. Sige, ito na lang. Ano yung period ng mga wave na to? Yun na lang. Ano yung period ng wave na to? Yun na lang. Period. Sige, tama na yan. Kung meron man nagbigay sa akin. Ayan, tama yan. Oo, okay na yan. Period pala. Mali ako nang type. Sorry. Ayan. Sige. Easy naman yan. Sige na, kaya nyo na yan. Ano ko na to? Siyempre, one period is from here to here, no? Bawal kunin yung wavelength kasi X versus time yung binigay ko. Never mind, sorry. My bad. Yan, 4 seconds. Tapos yung isa, 2 seconds. Period. Kasi agad dito. Di ba? Okay. Yan. Next, types of waves. May dalawang klase na wave, no? Transverse wave. Type of wave wherein the motion of particles are transverse or perpendicular to the motion of the wave. Ano ibig sabihin nun, guys? Ayan, see? Ito yung, ano sabi? Motion of particles are transverse. Di ba ito yung velocity ng wave? Ito yung motion ng particle. Akyat baba lang siya, di ba? Transverse kasi perpendicular direction, no? Ayan, this is just another example. See? Yung tinitignan natin, points, focus, di ba? Yun yung pag-travel ng wave, pero yung motion ng particles mo up and down. Tawag pala dito is simple oscillator, simple harmonic oscillator, no? Ayan. Ayan, cool GIF, no? Cool GIF. Okay, longitudinal wave. A type of wave wherein the motion of particles are along the motion of the wave. Tapos meron tayong dalawang terms. Compressions, kapag magkadikit. Expansion, kapag nag-expand malamang. Diba? Yan, example. Diba? Itong part na to, compression yan. So, and yung expansion is itong part na to. No? How do you know the wavelength? Kunin niyo yung gitna. Yan. Wavelength yan. Pwede rin naman to. Pareho lang yan. Wavelength yan. Ay, wavelength yan, no? Wavelength din yan, no? Basta gitna ng compression, gitna ng dalawang successive compression, gitna ng dalawang successive expansions. Yan. That's how energy is transported. Particle motion and the wave motion is at the same direction. Diba? Kita naman? Yan pa yung isa. Ang napapansin natin, sa mga compression, mas dense yung mga particles natin, di ba? And that's how actually sound works. Shown here is the waveform for sound, no? Waveform for sound ito. Yeah, this is what happens kasi sound is actually pressure waves, no? Pressure waves. So kapag compression, mas pressurized siya sa air. Kapag expansion, hindi masyado. Yon, that's how sound works. We'll discuss more that later. Ayan, mamaya din. Ganun siya. Ganun ang longitudinal wave. Ganyan yung nangyayari sa sound. Naririnig natin yung mga ganito. Longitudinal waves. Ano yung mga part? Yun nga, wavelength, distance between successive compressions or expansions. Frequency is the number of compressions that pass a point in per second. Then wave speed is the speed with which compression appears to move. It is equal to the, ano pa rin? V equals lambda F pa rin. V equals lambda F. So, ano yung speed ng wave? Example, hindi given yung mga lambda F sa'yo, no? Ano pa yung mga option, no? Ano pa yung mga option? For a standing wave or transverse, we'll discuss what a standing wave is later. Kasi sa string siya, di ba? Yung speed ng wave doon is determined by the tension on the string, Ft, and mu is called the linear density, mass per unit length, no? Mass per unit length. Yun ang unit niya. Example, may nakita kayong grams per meter, grams per centimeter, ganun. Ang tawag doon, linear density. Sige, try this out. Sige nga guys, let me test you. Ito, game. Two minutes. O sige, 3 minutes na. Or 5 minutes. Sige, kahit hanggang 5. Sige. Go. I'm waiting for answers. O sige, ano mo yung kailangan nyo gawin? Kailangan nyo kunin yung speed ng thing. Speed dito, no? Ano ma? Square root ng tension over mass density. Linear mass density, no? Makukuha nyo yung mu kasi meron tayong kilograms per meter. No? Meron tayong so, sige. Use the given information. Yan. Good job. Sige. Pag gina-heart rate ako, tama. Yun. Sige, 1 minute. Manuel, syempre, it's good na wait lang, 100 square root of 2. Ano ba yung 100 square root of 2? So, P6, bawal yan, no? Ayan, tandaan mo na. 30 square root of 2, wrong. Mali yan, Manuel. Sige, it's okay. Sige, let's discuss. Time's up. Okay. Game. Sige. Ito. Siyempre, ito. So, kunin natin yung Kunin natin yung velocity, no? Velocity is square root of ft over mu, di ba? Square root of ft over mu. Ft is 1,000. Then, mu is mass per line, mass per linear unit. So, 15 kilograms divided by 300. We get this. This is equal to 140 meters per second. Tapos yung frequency, di ba? V equals lambda f, di ba? So, we just use that formula, then we'll get something around this, no? Good job sa mga nakakuha. Speed of a wave. Ito, we won't deal with this na. Basta yan. E is the elastic modulus of a material and rho is its density. Di naman to dinidiscuss, no? As long solid radiant na travel. Di naman to dinidiscuss sa school. Then, kapag fluid naman yung travel niya, bulk modulus of a material and rho is the density of the fluid, no? Tama. Skip natin to. Yan. Energy transported by a wave. For a sinusoidal wave of frequency f, the particles move in SHM as the wave passes, di ba? Nung na-discuss natin sa SHM, yung total energy, ito kasi potential, no? Assuming na hindi pa gumagalaw is 1/2 Ka squared, di ba? Kahit saan yan, transverse or longitudinal, di ba? The energy transported by a wave is therefore proportional to the square of its amplitude, di ba? Okay. Ngayon, intensity, I don't think na-discuss pa sa inyo to dati. The intensity is defined as the power or energy per unit time transported across unit area perpendicular to the direction of energy flow. Ano sabihin yan? Example, we have this spherical mass, di ba? Spherical mass. Saan na yung ano? Yung intensity is the power delivered over this spherical surface, no? Perpendicular. Kasi yun naman yung dinadaanan niya, di ba? Perpendicular. Diretso, head on. Di ba? Ngayon, most waves transport energy in all directions. Di ba, kung isipin naman natin, example, meron sa space, di ba? Example sa space. Although, hindi technically possible yon kasi walang air sa space, di ba? Nagta-travel lang ay light kasi vacuum ang space. So, example, sa space, kaya yung sun, pag lumabas ka, di ba, bola siya of light. So, kahit saan ka, makikita mo yung sun kasi nag-spread yung light everywhere. So, yung intensity na yon is P over the area 4 pi r squared. No? Kaya lang, considering two distances from the source, the following relationship can be deduced. So, maglagay ka lang ng I1 equals P over 4 pi r1 squared, tapos I2 equals P over 4 pi r2 squared. Yan. Kasi same source to same source. Same power, nagkaiba lang yung distance. If you solve that, di ba, P over 4 pi r1 squared, right, 2 equals P over 4 pi r2 squared. Tapos, divide I2 by I1, you'd get this relationship. Yan, no? Inverse square law ang tawag dyan. Ngayon, sige nga, let me test your understanding of the formula. Ito. I'll give you 3 minutes for this. Ano lang to lahat, guys? Plug and play, di ba? We'll start sa board. Tigay na yung board and just gonna list down everything that, all the formulas we have discussed as of now, no? Para meron kayong pwedeng balikan habang nag-discuss tayo. Kasi marami tayong di-discuss ngayon na formula. And I'll try to use the computer screen as much as possible. Mm. Tapos kung mapapansin nyo sa, kung mapapansin nyo sa formula, magkabaliktad, no? 75 meters. Teka, let's see. Teka lang, Mo. Yes, tama, 75. I'm just gonna heart reacts. Lahat nung nagbigay sa akin ng sagot, tama kayo. Good job. Just wait a bit for the others. Yan. Okay. Sige, okay na yan. Let's see. So, if you look at this, yan, 75 meters kasi I1 squared over, I1 over I2 equals R1 squared over R2 squared. Just use the formula, no? Then we can have it. Okay. Sige. Good job, everyone. Ito naman. Easy lang to, pero let's go. Lahat ng formula nilista ko na sa board. Watts per square meter. Watts per square meter. Mo. Yun. Megan, baka may mali ka somewhere. Pero sige, let me check na rin, no? I1 over I2 equals 4 1 times 10 to the 6 divided by 16. Yan. Baka Megan, baka nag ka somewhere. Baka napagbaliktad mo yung formula, ganun. Sige. Okay, sige, let's discuss. Ano lang yan? Diba? I1 over I2 equals R2 squared over R1 squared. So, 400. Yan. There we go. 62. 400 squared over 100 squared. Tapos ito, 1 times 10 to the 6. Tapos divide lang. Solve for I2, you get 6.3 times 10 to the 4th watts per square meter. Yun yung tamang unit, okay? Remember. Ito naman, standing waves and resonance. Ito na. 125. Okay na minutes tayo. Sige, 25 minutes pa lang. Okay. Sige, game. So, when a disturbance or a wave reaches a boundary, mag-reflect siya, di ba? Propagate in the opposite direction. Upon reflecting off the boundary, the reflected wave would interfere with the incident wave. We're going to talk about this mamaya. What interfere means, no? What interference means. Mamaya pa yan. At certain frequencies, resonance frequency, yung generic term for these kinds of frequency, no? Pag may narinig yung term resonant frequency, yun yung common term. The effective wave results from the superposition or pag-add ng dalawang wave, pagsama ng dalawang wave na yon, papunta at saka pabalik, would appear to be no longer propagating. Kumbaga, hindi na siya, kasi di ba pag, pag ka na rope, di ba, parang nag-move forward yung rope, di ba? Pero, if you look at it, after some period of time, para papansin mo, hindi na siya gumagalaw at all, no? And that is called a standing wave. To have a better picture, this is how it looks like. Yan. Ito yung mga nag-i-interfere na wave. Pero in essence, kung titignan mo yan nangyayari na yan in real life, ito lang makikita mo. Ang tawag dito, standing wave na. Okay? Sige. Ang tawag sa points nito, destructive interference, we would know more about that later, or yung point na hindi siya gumagalaw, no? Node yon. Pag antinode naman, siya yung mga nasa crest and trough, di ba? Kung papansinin niyo. There we go. Resonant frequencies. Frequencies kung saan napoproduce tong standing waves na to. Nodes are points of zero displacement. Antinodes, points of maximum displacement from the equilibrium. Or yung mga crest and troughs natin. Nandun yung mga antinode, no? Ayan. Better illustration, no? Node, antinode. Kung papansin natin, the wave pattern, pareho lang siya, no? Kapag fixed yung mga nodes and antinodes, so pareho lang. No? Pareho lang. For standing waves on a string, both ends are held fixed at nodes, no? Kumbaga, tingnan natin dito, sa string, parating ganyan yun, no? Kasi pag hindi mangyayari yan. Hinahawakan dito, tsaka fixed sa dulo, di ba? Yan. Tapos, okay, yun na importante. To determine the resonant frequencies, though, we first note that the wavelengths bear a simple relationship to the length of the string. Bakit? Let's see, The lowest frequency is called the fundamental frequency. Corresponds to one antinode or loop lang. Kasi, you'll see later. The other natural frequencies are called overtones. Second natural frequency is the first overtone, or also harmonics, no? The fundamental frequency is the first harmonic. Sige. So, just remember these terms for now. For standing waves on a string, where n is the n of harmonic, there are n loops, n minus 1 overtone, n plus 1 nodes, and n antinodes. So, sige, let's see. Marami akong sinabi, no, na hindi natin na-imagine kung ano yung mga ibig sabihin yan. Sige, let's see. Ito. Remember this table, no? Ito lang importante dyan, guys. Ito. Ano importante dyan? Siyempre. Teka, ha? I'll just remove the ink. So, sige. Let's discuss more, no? Ano sabi? Tingnan natin dito. The lowest frequency, called the fundamental frequency, corresponds to one antinode or loop. Ayan nga naman, no? Sa first harmonic, ito lang. Diba? Yan lang siya. Kung napansin natin, ano yung wavelength niya? Diba ang buong wavelength is something like this, diba? Parang ganyan. It's just half. Diba? Napansin niyo? So, yung length is just half the wavelength, diba? It's just half, length is related to the wavelength kasi yung wavelength nitong wave is just half, no? Okay. Kasi kapag nag-second harmonic na tayo or first overtone, ayan, here are our terms, no? Ano lang yun? Yung harmonic overtone Those are used to describe kung anong mode of natural frequency na yung describe natin. Okay? Pag first overtone or second harmonic, napansin natin, ito na siya. Dalawang loop, di ba? Ito isa lang, ito dalawa. Yun, 2 loops na. Tapos ito yung antinode, 1, 2. Tapos tatlo yung node, 1, 2, 3, di ba? Yun. 2 nodes, 1 antinode. Yeah, so just going over the terms in case you forget, L equals lambda, di ba? L equals lambda. Then, second overtone or third harmonic, yan pa rin, no? 3 lambda over 2 kasi 1, 2. 1 and 1 half, no? So, 3 halves. So, wavelength as a function of L, solve for that, then there we go. We have this general relationship already. Lambda equals 2L over N, and F equals Vn over 2L, where V is the wave velocity dahil nasa string siya is Ft over mu, no? Paki-screenshot or capture screen na lang yung table na to kasi gagamitin natin to ng we'll answer exercises kasi, no, on this. Paki-screenshot na lang or picturean yung table para hindi nyo malimutan, no? Sige. Tas ito rin, you find this useful, picturean or paki-picturean or paki-screenshot na lang din. I'll give 5 seconds. Okay. Sige, that's enough. Ayan. 5 seconds ulit. Baka lang meron pang dito nakano. Okay. Ito na. Sige. I'll sige, go. Try nyo I'm just curious if kaya nyo. Sige, try nyo. I-discuss ko rin yan on board mamaya. Fundamental frequency, remember, that is the first harmonic, no? First harmonic yan. Kumbaga, at fundamental frequency, n equals 1. Okay, always remember that, no? N equals 1. Kung tutusin sa grade 10, itong topic na to yung pinakamadali na. And ito na yung last lesson natin sa physics, by the way. Ang tatanong ko sa inyo, sige. Sige, I give 5 minutes for this, no? 5 minutes for this. Kaya let's see, ha? Galing. Good job. Okay. Good job mo. Sige, go. 3 minutes or 2 minutes. Yan ako naman to, i-discuss ko sa board. Sige, kahit yung tension na lang muna. Ako na mamaya sa... If meron kayong sagot for the harmonics, go. That's good. If not, sige, I'll take care of the latter part of the problem, no? Sige, 2 minutes pa. Pero itatanggalin ko na naman lahat to. Yeah, sige mo. Tingin mo, paano mo makakuha yung 3 and 4? Yung technique yan. Easy lang yan. So, okay, yung mga nagbibigay sa akin, go. That's really good. Ayun, diba? Sunod-sunod na siya, no? Ayun. Diba? Galing, diba? Okay. Sige, good job sa mga nagbigay sa akin. Sige, I'll discuss na muna. Good job. Tama yan, Melissa. Melissa pala. Kung ano man yung binigay mo sa akin, that's correct. Good job for trying. Sige, let's see Let's solve. Look at the whiteboard na lang. Refer to this for the given, no? Okay, how much tension must it be for the fundamental frequency to be 131 Hertz, no? 131 Hertz. Tama ba? Okay, Kim. Diba? Vn over 2L. F equals Vn over 2L. N equals 1. So, okay, game. Tas 1 over 2L times, ano yung V? Square root of Ft over mu. Next, ano pa? 1 over 2L times square root of Ft over M over L, di ba? Tatamad ako magsagot, so isosolve function ko siya. Paano siya isosolve function? 1 over, ano ba sabi dito? 1 over 2 times 1.10 times square root of tension X over M over L. So, 0.009 divided by 1.1 equals 131. Shift solve. Yan, 679 or 680 newtons, no? Whatever suits you. You would get that. Yes, tama yan. Yes, tama yan. Megan, tama yan. Sorry, hindi ko nakita agad. Okay. Sige, what's next? Ayan, di ba? What are the frequencies of the first 4 harmonics? We have the first one already. Do I still need to use yung F equals Vn over 2L? Wag na. Alam niyo kung bakit? Kasi, the next one is just, kumbaga sunod-sunod sila. Gets nyo? Diba, F equals V over 2L equals 131. F1, F2 equals V times 2 over 2L. So, times 2 lang ito, 262. F3 equals 393. F4 equals 524. And so on. Yun lang siya. Galing, di ba? Yun lang siya. So, sige, if I'm going to ask you, what is the eighth overtone? What is the eighth overtone? What is the frequency of the eighth overtone? Type ko yung tanong ko sa, type ko. Let's see. Okay. Sige. Tama. Ay! Teka. Oy, 8 overtone sabi ko ah. Wait, ano ba? Ay, wait. Teka, ako'y nalito. 8 over... Yes, sorry. Tama, 1179. Ay, sorry, mali pala. Dapat n equals 9. Sige. Go. Sige, mag-ano muna. Sige. Wag na ako mag-menti kasi matagal pa eh. Game. Para lang masanay tayo, no? Sige, type lang kayo. Yes, yan. Okay. Okay, sige. How many loops? Ay, hindi, sige. What is the frequency when the standing wave has 10 loops? What is the frequency when the standing wave has 10 loops? What is the frequency when the standing wave has 10 loops? Mo, sabi ko, what is the frequency when the standing wave has 10 loops? Okay, tama si Manuel. Good job. Hindi. 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 Ulitin ko yung tanong ha. What is the frequency at the harmonic where the standing wave produced has 10 loops? Yan. Good job. Para na masanay tayo, no? Sige, last two after nito. Yes, space tone na given pa rin, Mo. Tama. Unless, pero unless what? Sige nga, I'm interested. Good job. Good job. Okay. Sige. Okay, good job sa mga good job sa mga nakakuha. Sige. Ito yung last kong tanong sa inyo, guys. Oh, this is a challenge. No? Let's see if it's yung concept. Ito, gawa ko lang to ngayon. So, two successive harmonics have frequencies. Two successive harmonics have frequencies 250 hertz and 343 hertz. Two successive harmonics, ha? Dalawang successive harmonics. So, first question is, what is the fundamental frequency? And next is, what is the 10th harmonic? What is the frequency? What is the frequency at 10th harmonic? Three minutes. Ay, 5 minutes. Sige, 5 minutes. String to, sa string pa rin to, sa string. Ayan, ulitin ko na yung tanong. The frequencies at two successive harmonics are 250 Hz and 343 Hz. What is the fundamental frequency? And next, what is the frequency at the 10th harmonic? Good job. Yan. Okay. Sige. Go, go, go. Yan. Kuha niyo yung concept. Good job. Good job. Sige. What? Sige. Sige, last 1 minute. Okay, sige guys. Game Let me discuss. Sige, actually dapat kasi mabilis lang siya. Oh, look two successive harmonics, no? Two successive harmonics. NV over 2L equals 250. N times V plus 1, N plus 1 times V over 2L equals 343. Subtract natin yung isa, makukuha natin na V over 2L equals 93. Diba? Which is exactly our fundamental frequency, no? Which is exactly our fundamental frequency. Kasi N equals 1 para dyan. Diba? Ito, 93 Hz. Next, what is the 10th harmonic? 93 times 10 equals 930 Hz. Sige, I hope you got that. Kasi marami tayong di-discuss. Okay lang, we'll practice more of this sa problem set. Discussion natin next time. Okay? Interference and diffraction. Diffraction. Okay. Sige. Interference is a phenomenon that refers to what happens when two waves pass through the same region of space at a time. So, okay. Kung papansin nyo, di ba yung tubig, water waves? Teka, wala ba akong picture dito? Wala. Yung water waves, kapag pinagsama mo yung dalawa, di ba? At some point, sobrang taas to wave. At some point, sobrang wala. Nag-cancel out. Walang wave at all, di ba? Yun ang ibig sabihin ng principle of superposition. So, in the region where the two waves overlap, di ba? The resultant displacement is the algebraic sum of their individual displacements. Sa crest, positive displacement yon, sa trough, negative displacement. Remember that. So, kapag destructive interference, crest and trough, no? Nasa gitna yan. Diba? Crest and trough. Tapos kapag ito naman, constructive, ayan, no? Nagsama yung dalawa. Baliktad yung ba yung ginawa ko? Okay. Baliktad to guys baguhin ko na nga. Wait lang, nainis ako. Baguhin ko na. Destructive. Destructive to. Constructive. Yan. So, at constructive interference, ayan, greater than the displacement of either separate pulse. Okay. By the way, sa wave pulse, yung bawat iteration ng wave. First pulse, second pulse, third pulse. Kung pang ilang alon yung dumating sa'yo. Layman's terms, no? Destructive interference, two waves have opposite displacement at the instant they pass each other and they add to zero. So, walang wave, no? Partially destructive. Of course, when they don't have the same amplitude. So, let's see. Yan. Ito, di ba? Destructive interference, kasi at the moment na nag-overlap, wala. Ito, tong isa, constructive, di ba? Ayan, no? Tumaas na sobra. Parang tumayo. Diba? Okay. Ito. Constructive. Destructive. Kasi, no? Yan. Tapos ito. Ito rin. Cancel. 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 Di ba? Ito naman, partially lang. Kasi, mas matangkad yung isa. So, may matitira pang net displacement dito para maging ganito yung wave. So, when the crest and troughs are aligned as in for constructive interference, the two waves are called in phase. So, let the distance from S1 to any point be R1 and let the distance from S2 to P be R2. So, for constructive interference, dapat integer multiple ng wavelength or path difference or phase difference, no? Dapat yung distance nila is an integer multiple of the wavelength, no? Yung distance between yung difference between the distances, no? Path difference or phase difference. And kapag destructive naman, completely out of phase. Ito naman siya. half integer multiple. Half integer multiple. Basta yung m is always is always an integer, no? Positive man or negative. Yeah, this is what I mean. See? Ayan. Yung difference nito is um, yung difference nito is 2 wavelengths only. Pag ganyan, integer number of wavelengths. Okay siya, no? Constructive interference. Kapag destructive interference naman, baliktad, half integer number of wavelengths. Ito, negative 2.5. Right? Yan, R2 minus R1, negative 2.5. So, destructive yan. Tsaka tignan mo, pag, look at this. Pag half wavelength difference, tignan nyo to. Ayan, no? Nag-interfere siya destructively. Opposite. Ito naman, nagsama yan, no? Lalaki yan, no? Okay. Ito pa. Masyado complicated to, no? Basta yung red is constructive interference. Basta may nag-intersect. Constructive yun. Pag destructive, yan, nasa gitna lang. Yung mga ganyan, no? Anywhere dyan, destructive yan. So, try this out. Okay, tell me, ano yung points of constructive and destructive interference? Sige nga. Ano dyan? Sa GHIJKLMNO. Destructive tsaka constructive interference. Kumbaga, sorry, let me clarify. Dalawang magkahiwalay na wave to. Dalawang magkahiwalay na wave to. And constructive and destructive can happen at the same time, di ba? So, from these points, ano dito yung constructive, ano dito yung destructive, no? It doesn't have to be completely destructive, completely constructive, no? Basta yun. Sige, I'll take this for now. Sige, let's classify the points, no? Sige, ako na muna. Kasi mahirap. C. Let's examine G. Ito siya, di ba? Parehong pataas yung wave. Constructive interference. Yun, good job, Megan. Good job. Hard practice yan. There, you got it. H. Tingnan nyo. Yung isa pataas, isa pababa. So, dapat destructive yung H. Yung I, ganun din siya, oh. Yung isa pataas, yung isa pababa. Destructive. J, let's see. Parehong pababa. Ingay naman sa labas namin. O, yun. Laksan ko lang, no? Yung sa J, ayan, no? Pareho na sa baba. So, dapat constructive. K, magkahiwalay. Destructive. L, magkahiwalay. Up and down. Destructive. M, constructive kasi parehong pababa yung wave. N, ganun din. Parehong pataas yung wave, constructive. O, parehong, magkaiba. Destructive. So, in short, G, J, N, M, G, J, M, N is constructive and the others are destructive. Good job. Ito naman, sige, medyo malabi yung figure, no? Sige, ako na lang. Ito, yung mga may tuldok. A, B, C. Teka, wait lang, yung A and B, at least, sila yung sure tayong constructive, no? Tapos yung iba, kasi take note, magkaiba yung, ano, di ba? Magkaiba yung mas thick na circle sa mas maliit na circle, no? Pag yung, ba't gano'n? Okay. Ayun, may nalimutan ako sabihin. The waves and the thick lines represent wave crests and the thin lines represent wave troughs, no? Ayun, yun pala yung nalimutan ko sabihin. Sorry, nalimutan ko lagay dito eh. Pag thick, wave crest. Pag thin, wave trough, no? Sige, let's examine. Dito, nagsalubong yung dalawang crest. So, constructive. Dito rin. Ito, nagsalubong yung crest tsaka trough. So, destructive dito. Ganon din dito sa F. Ganon dito sa E. Ganon din sa D. No? So, ang constructive interference is A and B and the others are destructive. Next, diffraction. So, waves spread as they travel. No? So, kapag example, kasi maganda to pag experiment eh. Ewan ko lang kung magawa nyo. Sana magawa nyo sa school to. Kasi, pag nagpadaan ka ng tubig through a gap, tulad dito, ayun no, mag-spread out lang siya. Like this. No? And pag naman tumama yung water sa isang, sa isang obstacle, ganun din. Magpo-pass behind. No? Ayun no. At tawag dito, shadow region. Yan. Gusto mo yung ganun siya. Ayan. The amount of diffraction is approximated by wavelength over L. Radians yun, ha? Theta is the angular spread, no? Tulad nga nito. If you look at this. Diba? Kapag dilitan natin yung wavelength, pag dilitan natin yung slit width, lalaki yung theta. Pag naman nilakihan natin yung slit width or L, liliit yung diffraction, no? Kumbaga, pag tayo, ganyan lang. Yan nakayet. Pero pag nilitan mo yung slit width, lalaki yan ganyan. 1, 2, 3. Yung mga ganun. Imagine that has lines na arcs, small arcs, no? Pag daw yung wavelength, nilakihan mo, wavelength ng wave mo, nilakihan mo, syempre, lalaki rin yung diffraction. Kapag nilitan mo, liliit. Okay, sige. Ayan pa, di ba? More illustrations. Di ba? Small wave, a small obstacle, more diffraction. Long wavelength, less diffraction. More diffraction din. Ito, less. No? See? Okay, sige. What can you do to increase? Ito, conceptual. Ano dito? Sorry. Okay, basta, how can you, kasi yung, sige, just a bit of background. Young's double slit experiment. Tama, no, isa lang. Dapat B lang. Ang sagot dito, dapat letter B only. Bakit? Kasi ano yan eh, light diffraction yan. Bright maximum, ibig sabihin, kapag nagdaan tayo ng ilaw or laser, paano natin palalakihin to? Ayan, paano natin palalakihin yan, no? Lambda over L. Increase the width. Di ba? Theta. So, kailangan natin, kailangan palakihin yung angle, di ba? Siyempre, ito lang, no? Bilang. Para lumaki yung value ng radians natin. Okay? Next, ito. Madali lang to. Kahit i-voice chat ko na lang yung answer. Para di na kayo mag-type. Sige mo. Okay, yan. Sige, madali lang to. Sige, let's try it out. 7 point, get the difference between the wavelengths, no? 3 wavelengths, di ba? R2 minus R1 equals 3 lambda. It's an integer. It's an integer, no? So, ano siya? Constructive siya. Ito naman, 4.6. 7.3 minus 4.6 is 2.7. 2.7 lambda. Nasaan na yun? 2.7 lambda. So, it's not an integer multiple of 0.5. It's not an integer multiple. It's neither. It's just partially destructive or constructive, no? It depends on the situation. Hindi tayo sure. Ito, lastly. Sige, let me see. Path difference is R2 minus R1, no? So, ito. Dali, kayo muna. I'll give you 2 minutes. Pag yung mga tanong dito, parating total, no? Parating total constructive. Pag tinatanong kayo ng constructive or destructive interference, always assume na total, no? Totally constructive, totally destructive. B. Ayan, good job. Good job. Sige, so lahat ng mga sorry if medyo minamadali ko kasi yung mga ganito dapat to agad one look lang malalaman mo na. Okay, sige, let's examine. R2 minus R1, try natin isa-isa, equals M lambda, di ba? So try na natin, di ba? M equals R2 minus R1 over lambda over 500. So kailangan natin hanapin kung saan magiging whole number yung sagot. Pag divide natin by 500 yung path difference, no? 800 over 500 is 1.6. 1,200 divided by 500 is 2.4. 1,250 divided by 500 is 2.5. Pero destructive interference yon. Ay, yung huli, 1,500 divided by 500, it's 3. Whole number. So, tama yon. Dapat yon, no? Dapat yon. Eto, dalawa yung sagot dito. Sabihin ko na. Game. 2 minutes. Destructive interference, ha? Destructive interference, guys. Sige, ito, I'll wait for others, no? I'll wait for all of you. May isa pa, Jeremy. Destructive interference, ha? Sige, let's discuss, ha? Okay, game. Tingnan nyo, ha? R2 minus R1 equals 600 equals M lambda, di ba? Take note, dapat may 0.5 yung sagot kapag di-divide natin by the wavelength, yung path difference. Sige, 600 divided by 240 is 2.5. Okay, tama na agad to. Kasi may 0.5. Letter B, 600 divided by 300. 2. Hindi, ito constructive to. Constructive to. Mali to. Letter C, 600 divided by 400. 1.5, no? 1.5. Letter D, 500. 600 divided by 500 is 1.2. So, dapat hindi. Hindi ito. So, letter A and C. Dapat. Before I continue, nagigets ba yung dinidiscuss ko, guys? Nagigets ba? Before I continue? Nakakuha ba? Sige, sige. Yan na. Okay, that's good. Sige, let's go. Yeah, kasi marami pa tayo. Game. Reflection diffraction. Some new terms, tawag dito ray. Tawag sa ganito is wavefront, no? Yung ganyan. Ray yung parang backbone or skeleton. Wavefront ay yung waveless mo, no? To ray, wavefront, no? Ang wave, di parating ganyan, no? Take note, di parating ganyan. Pwedeng straight, pwedeng pa-triangle. Any shape actually, ang wave. So when a wave strikes an obstacle or comes to the end of the medium at in which it is traveling, at least a part of the wave is reflected by Newton's third law. So take note yung difference. Kapag fixed yung string, babalik siya the other way around, upside down. Kapag hindi naman fixed, pag ganun lang siya, same direction as before, no? So ano na important? Law of reflection. The angle of reflection equals the angle of incidence. Angle of incidence is defined as the angle. Ito lang important, yung incident ray. Ito itindan nyo yung ray, no? Makes the perpendicular to the reflecting surface or the wavefront makes it the surface, no? Angle of reflection, theta r is the corresponding angle for the reflected wave, no? Dapat equal sila. Kung ano man to, yun din yun. Tapos refraction naman, the wave speed changes and also the wavelength changes pag nagpunta na sa isa pang medium, no? Sa light, mas pa-discuss natin to, pero hindi natin di-discuss yun, kaya na yun. Okay? Tapos, ito tatandaan nyo, super important conceptual to, ha? When light travels into a new medium, the frequency remain unchanged. Okay? Tandaan nyo yan. Important yan. Okay? Ang nagbabago lang, di ba, V equals lambda F. Ang nagbabago lang ay V tsaka wavelength, no? So, yan. The law of refraction is given by this, no? Ang theta 2 ay angle of refraction. No, basta okay, doesn't matter naman. Basta, yung dalawang angle nila has that kind of relation. Di ba? Yun lang important, no? Yung isa dyan, angle of refraction, ay isa dyan, angle of incidence. Sige, eto, game. Easy lang to. 1 minute. Teka, hindi ko nasagutan to eh. Wait lang. Sine 44 over sine 33 equals sine 44 over sine 33 equals to sine 33 44 ito, mo, double check mo. I think baliktad ka. Yung mga sumagot ng 6.3, tama yun. Sige, 1 minute. 30 seconds. Yan. Sige, let's discuss. Ano lang, sine 44 over sine 33 equals to x over 8. Ay, sorry. Huh? Teka. Ano ba yan? Nandito na yun kanina. Equals. Sine 44 over sine 33 equals 8 over x. Yun. Sine 44 over sine 33 equals 8 over x. No? Solve that. We get 6.27 kilometers per second. Acoustics is another term for sound. Yun lang. Kaya nga acoustic guitar, acoustic bass, acoustic drums, lahat yon pertains to sound, no? Sound waves, yan, looks like this. Longitudinal pressure wave siya. Nasabi ko nga kanina, no? Kaya pag parang malakas yung sound, nararamdaman mo nagva-vibrate yung eardrums mo kasi by pressure yon, no? By pressure. Yan na, sabi ko kanina, di ba? Pressure, more pressure here. Higher pressure, lower pressure sa expansion. Ganun yung motion ng molecule kasi nga longitudinal wave siya. Speed of sound is this, no? Is this one. (331 plus 0.60t, no? 0.60t. Most of the time naman, air yung material. Actually, dapat, air yan. Speed in material plus 0.60t, no? Kaya lang ito, in air lang to, okay? 331 plus 0.60t. Where T is in Celsius. Celsius to, hindi Kelvin na, Celsius. So, ito, properties of sound actually is related sa ibang properties na discuss natin. Example, yung loudness, diba, ayun, kung gaano kalakas or kahina yung sound, malamang, no? Ang generic term for for waves is intensity. Then it depends on it manipulates yung amplitude or yung amplitude or yung nag-affect sobra ng loudness. So, it means na kapag malakas yung sound, mataas yung intensity and therefore mataas yung amplitude, no? Yun ang sabihin nun. Pitch is the highness or lowest of sound. Matinig ba? Mababa ba yung boses? Diba? Frequency. Depends on frequency, no? Pag mataas yung frequency, high pitch. Pag sa baba, low pitch. Below 20 Hz, infrasonic. Above 20,000 Hz frequency, ultrasonic. Ito lang yung naririnig natin. Audible sound range. Just for your information. Kaya yung mga animals, meron silang naririnig na hindi natin naririnig. Kasi nga, mas sharp yung ears nila sa atin. Mas kaya nilang kumuha ng mga sound below 20 Hz or above 20,000 Hz sounds, no? Manifested in wave, no? Siyempre, pag mas mahaba yung wavelength, pag mas mahaba yung wavelength, well, for a given sound, pag mas mahaba yung wavelength niya, mas maliit yung frequency. So, pag mas mahaba yung wavelength ng isang sound, assume na, agad yun, low pitch na agad yun, mababa yun. Kapag short wavelength naman, high frequency yun. So, pag short wavelength, asahan yung mataas yung sound na marinig nyo. But lastly, reality or timbre, hindi ako music person, so I'm not familiar with this. Basta, it's just how clean your sound is daw. How clean your sound is. No? Syempre, kapag bump yung waveform mo, don't expect na you get a very smooth sound, no? May putol-putol, ganon. Or kaya choppy, no? Yun yung mga terms to describe this. Intensity of sound, no? Ayan. Ito yung sasabi ko kanina, no? Intensity relates to amplitude. Loudness is a sensation in the consciousness of the human being and is related to a physically measurable quantity, the intensity of the wave. Loudness, sound level, is expressed in a logarithmic scale with unit decibel. So, pag yung decibel, dito nang galing yan, no? Beta equals 10 log I1 over I0. I0 is the reference level or threshold of hearing. Depende sa tao yan. Depende sa kung sino yung inaaral mo, no? Pero for now, syempre, tao yung pinag-aanuhan natin, no? Tao yung tinitignan natin dito. So, ito, sige. At a basic street corner, the sound level is 75. What is the intensity of sound there? Sige. Ayan. Just use the formula. Ito lang siya. Diba, beta equals 10 log I1 over I0. Diba? So, solve for I1. Diba? Solve for I1. So, B over 10 equals log. Marunong naman kayo siguro mag-log, no? Yan, dapat marunong na kayo niyan. I0. So, 10 raised to B over 10 times I0, no? Yan. We get 3.2 times 10 to the negative 5th watts per meter squared. Ito, sige nga. Concept check. Try this out. I'll give you 3 minutes. Kapag logarithms naman nakiyata sa math, di ba? Yeah, dapat. Ah, yes. Jab. Yes. Jab. Guys, ano lang ako ha? Share lang ako. Go lang. Okay, I'm back. Ito, sige, let's see ha. Let's see. Okay, sige, tara, let's discuss. Ganito lang yan. Look at the board na lang, ha? Look at the board. Di ba, log? Um, from here, di ba, 75 equals 10 log I1 over I0. Yun lang. Pansin natin, we are asked to compute ng tatlo pa. So, 4 na yung tao, di ba? So, technically, if iisipin mo yun, 4 times the intensity na yun. May properties of logarithms, 10 log 4 plus 10 log I1 over I0. Here we go. 75 plus 10 log 4 is equal to 81 decibels. 81 decibels. Sige. Next. Vibrating air columns, no? This is how instruments work actually. Vibrating string meron din. Kaya lang pareho lang siya kanina. Yung sa standing wave, pareho lang yung trend nun, no? Pag example, guitar, follows the same, no? Kaya actually may tono yung mga guitar dahil dito, dahil sa physics na to. It's actually cool, no? Kumbaga, yung bawat kasi sa music kasi merong mga terms na harmonic tones, 'di ba? Or kaya octaves, no? Dahil dito lahat 'yon, okay? So for standing waves on a string, mali. Teka lang ha. Mali ako na figure. Teka lang guys ha. Baguhin ko na. Okay, wait ha. Here we go. Speed of sound. V is the speed of sound. Kasi yun yung speed ng kinukuha natin. Speed of sound. Ayan, sige. Kasi may tatlong klaseng instrument, di ba? Merong wing, merong wind, merong string instruments. So, for string instruments, pareho lang to kanina. Okay? Kaya lang, nagbago lang, V is the speed of sound. Okay? Remember that. Yun lang naman nagbago. Next, standing waves in an open pipe. Waves in a string. Yan. Same lang kanina. Waves in an open pipe. Eto, pakipicturean na lang to or screenshot. Sige, give 5 seconds. Okay? Kasi ito yung, open dapat to, open dapat to. Shucks. So guys, pengi 2 minutes. Sorry nasira yung PowerPoint ko eh. Pasensya na. Yan. Teka lang guys Ito na, malapit na. Sorry talaga, na-distract tayo. Okay, balik tayo. Ayan. Sige. Isa pa. Ayan. Okay na to. Tama to. So, ito. This is our thing. This is the relationship, no? Sige, just a few notes. See, yung wavelength dito is still 1/2. Di ba? 1/2 wavelength lang yan. Kasi, yan, di ba? 1, 2. Ito yon. Kaya lambda over 2 pa rin, no? Same thing, pareho lang, no? Same as yung string. Kaya lang, speed of sound na to. Okay? Ayan. Remember that? Pakipicturean or screenshot. 5, 4, 3, 2, 1. Okay. Next. For standing waves in a closed pipe, ito raw. Take note, add harmonics lang. Add lang. So, n equals 1, 3, 5, 7. Yun lang yung meron dito. Okay? Hindi ko alam kung bakit. Pero, kasi, okay. I'll explain later. Yan, paki-screenshot or take a picture muna. 4, 3. Yan. Kasi, isipin nyo guys, pag second harmonic yung kinuha natin, magsasara siya, di ba? Magsasara siya, di ba? Gaganon siya, oh. So, pag ganon, hindi walang sound, wala ka maririnig pag ganon. Kasi, closed. Anti-node yun eh. Node yun. So, nag-cancel out yung sound, bale, if naging second harmonic yung kinukuha natin. Kaya yung meron lang ay third harmonics. Ay yung mga odd harmonics, no? Ito yung relation natin. Paki-screenshot or whatever is teka lang guys Teka. Okay guys, ganito na lang. Ayusin ko to, okay? May mali dito eh. Pasensya na Babalikan ko to next meeting bago tayo mag-problem set. Okay? Pasensya na. To, Doppler effect. Babalikan ko yon. Okay? Babalikan ko yon. Doppler effect. When a source of sound is moving towards an observer, the pitch, um, paano ito naririnig, guys? I'm sure, kapag may narinig yung race car, I'm sure na narinig din naman na to. Tapos bigla siya lumalapit sa'yo, di ba? Di ba? Tataas bigla yung sound. Tapos habang palayo ni race car sa'yo, parang ganun, di ba? Lumolower yung pitch. So, nag-change yung pitch or frequency depending on where the object is towards you or moving away from you. It's true by relativity, no? Pero hindi pa natin dinidiscuss yun. For all cases of the Doppler effect, F prime equals F times V sound, velocity ng sound, plus minus V observer over V sound minus plus V source. Ano yung mga sign convention natin? Basta tandaan nyo, kahit di nyo tandaan yan, basta tandaan nyo, kapag moving away yung tao, moving away yung observer or yung source, yung speed niya negative. Ang speed niya ay positive, no? Ang speed niya ay wait. Tama. Pag moving away, yung source o yung observer, positive yung speed niya. Ayan, positive yung speed niya. Okay? Tatandaan nyo yun. Kapag baliktad naman, observer moves toward, or kaya yung source moves toward something stationary, negative siya, no? Negative. Kasi ano yan actually? Relative velocity, no? Relative velocity yan, yung mga yan. So, depende sa ginagalawan ng tao or yung observer or yung source mo, that's how design convention works actually. Sige, let me show you some examples. Sige, ako na muna dito. Look at the board na lang. Okay, ito dito, nalimutan kong sulat, V sound equals 343, no? Meters per second. What frequency will you hear if you are at rest? Ako rin at rest, no? And the police car moves at 25 meters per second. F prime equals F times V sound, 343. Okay, ano rin yung sign convention natin? Kapag moving towards you, pag toward, dapat negative, no? Dapat negative. 343 minus 25 over 343. Wait lang guys ha. Shucks, nahiya ako sa inyo guys. Teka ha. Mali yung tinuro sa inyo. Dapat. Okay guys, lika. Balikan natin ulit ha. Balikan natin ulit. Okay, ganito dapat. Baliktad ako. Pag towards, positive yung sign. Pag away, negative dapat. Okay, one more thing to think about, no? One more thing to think about. Ito, kapag papunta sa'yo yung isang source o yung isang observer, diba? Dapat tataas yung pitch. Tataas yung pitch dapat, no? Tataas yung pitch. So, tataas yung frequency dapat. Tataas yung frequency. So, that is one way to remember your sign convention. Okay? Game. Ito, dapat plus, no? Dapat plus. If we get that, 1716. And yung isa naman, baliktad. Take note, at rest, kaya plus 0 yan, di ba? Equals to, equals to 1483 hertz. Ito raw. Oh, sige. Ako na muna dito. Follow my logic na lang muna, no? For the sign convention. Sige. Listener, ito raw. Kasi pwede rin yung Doppler effect kapag pareho ng direction ginagalawan yung ng tao. What frequency does the listener hear? So, nandito siya, yung listener, no? Listener. So, dapat you expect dahil mas mabilis yung tao, mas mabilis yung siren, di ba? So, you expect lalaki yung, hahaba yung wavelength, no? Or dapat, mas maliit yung frequency. Dapat, mas maliit yung frequency dapat. Kasi inaasahan mo, lalaki yung wavelength. Kasi nga, mas mabilis yung sinusundan mo. Okay? I hope you get my logic. So, F prime equals F times 343 plus V source over V sound. So, plus observer over 343 plus 45. So, if we get that, that is 277 hertz. Nalimutan kong yan. Yan dapat. Ito. Sige, I'll take everything na nga muna. Oh, ito naman. Look at the PowerPoint na lang for the given, no? Source, object. Babalik siya. Reflected kasi. Diba? So, dalawang Doppler effect yung mararamdaman dito. Kita naman kung bakit. Yes, dapat ganon. So, let's see. So, dito muna. Doppler effect 1. F prime equals to F times speed of sound is 343 pa rin, no? 343. So, 343. Dahil gumagalaw yung object papunta dito, ito siya. So, you expect the object to hear a higher frequency dapat. Diba? Kasi, liit yung wavelength eh. That's 3.5. Stationary. Teka guys let me check my So equals to 5,000 times 3.5 over 342. 5,051 hertz. Ayan. Kaya lang, babalik yung sound dito, no? Babalik yung sound. Ngayon, dapat, in-expect mo, tataas ulit yung frequency, no? Tataas ulit yung frequency dapat. Nakuha ba, guys? Nakuha ba? Nakuha ba? Nakuha ba? Ay, wait! Teka, sure yung sa Doppler kanina. Teka, let's see, let's see, Sorry, sorry. Wait. Um, Sige, let me see. Dun sa Doppler kanina, dapat lalaki siya. Ayun sa Doppler. Hindi po ba... Teka, Sige, let me resolve this na. Sorry, guys, Times... Oh... Sige. Okay. Next meeting, di-discuss ko ulit yung Doppler effect, no? Di-discuss ko ulit yung Doppler effect. Promise. Ano nang talaga, nalito ako. Okay, nalito ako. I'm sorry. Sige, let's proceed to the last topic muna for today. Interference in sound, no? Pasensya na, guys. Pasensya talaga. I hope you understand, no? Pasensya na. Next meeting ulit, di-discuss ko yung yung vibrating in air columns tsaka itong Doppler effect. Okay? Sorry talaga. Okay, interference in sound is called beats, no? Yun nga, as we know kanina, what happens when waves pass through the same region of space at the same time? So, the principle of superposition states that, yun pa rin, no? Same lang sa kanina. So, constructive interference, baliktad pa rin to. Dapat maximum yung displacement. Itong isa, dapat magka-cancel, no? Then, partially destructive kapag di same yung amplitude. So, ganun pa rin, same kapag constructive interference in phase, then integer multiple ng wavelength yung phase difference. At kapag destructive interference naman, half integer multiple, no? Half integer multiple. Ito yung same thing kanina. Ito, sige nga, using yung natin kanina, using yung natutunan natin kanina, let's try answering this, no? Game. Detect destructive interference tayo, destructive interference. Tapos, 150 Hz yung sound. Sige, let's see. Okay, so dapat, okay, sige. Hindi important to, guys. Hindi important to. Itong distance na to, no? Hindi important yan. So, ito yung person natin, no? Ito yung person natin. Let me draw na lang yung figure sa board. Speaker. Ito yung tao. how far should this person be from the second speaker to detect destructive interference? So, wala tayo dito. Diba? So, looking at this, di ba? Dapat minus R2 equals ano, di ba? Dapat wavelength over 2 plus minus lang, di ba? Kahit isang wavelength lang. Kasi pag dalawa natin, magiging significant na yun, di ba? So, it's either mas malapit siya sa pangalawang speaker or mas malayo siya sa pangalawang speaker, no? So, we just solve for this. 4.0 equals R2 plus minus lambda over 2. Para natin makuha yung lambda. Diba? Lambda equals V over F. Diba? So, that is equal to 343. Yung sound frequency natin is 1,150. Yan. Then, we solve it here. Makukuha natin na 0.30 ito. Tapos, ilagay lang natin dito. R2 equals 4.0 plus minus lambda over 2. So, it's either equal to 4.85 meters or 3.85 meters. 4.15 or 3.85 meters. So, okay, we'll try more of this next time. Tapos, last is beats, no? Basta yung tawag, interference according to time, we look at the time, di ba? Tawag dyan, beats, okay? An interesting and important example of interference yung beats. Bakit? Kasi, if you look at yung beats, ibig sabihin niya, if two sources are close in frequency but not exactly the same, yung sound waves interfere with each other. Then alternately, nag-rise and fall yung position ng sound natin. And it's easier to explain kapag may figure eh. Ito, see? Ayan, okay, ito na lang. So yan, may dalawang sound wave tayo na magkalapit. Then what actually happens is like this. Diba? Kaya tayo may music and beats eh. Dahil sa pagkakaiba-iba ng sound waves. They add up in a way, very special way, such that sobrang ganda na napapakinggan natin. So yan, this one whole waveform is called a beat. No? Is called a beat. Yun lang siya. Ito ibig sabihin niya. And how do we get the beat period? No? How do we get the beat period? It's just the difference of these frequencies, di ba? 1 over the difference of that frequencies. So yon, the beat frequency is defined to be the difference in frequencies of the two sound waves. Yun na siya. So, ito, if I were to answer this example, ito, let's see. Vibrating string, 20 beats are counted in 5 seconds, no? 20 beats are counted in 5 seconds. So, yung beat frequency natin is 4 Hz. Kasi 20 beats per 5 seconds, di ba? Yun yung beat frequency natin, 4 Hz. So, ano na yung posibleng frequency ng guitar string? It's either 404 or 396 lang. Kasi yun lang yung magkakaroon ng beat frequency na 4 Hz. Okay? Yun lang. Di ba? Guys, pasensya na. I'm going to clarify ulit yung I'm going to spend the first few minutes of the next session to clarify yung Doppler effect and to fix yung yung sa open air column natin, no? Sa closed air column pala. Sige guys, yun lang. Pasensya na talaga. I hope that you're having a great day. Happy birthday ulit kay Mo. Sige, yun na muna guys. Okay na tayo. Sige, yun lang. Bye-bye.